All right, let's jump right in. We're going to talk about something that's, well, pretty much everywhere. Java. You might not code in it, you might not even think about it, but I guarantee you rely on it. It's kind of like this invisible engine that's just humming along in the background, powering so much of our digital world. So yeah, let's get into it.
And that brings up a really fundamental question. I mean, think about it for a second. You've got Android phones, huge enterprise servers, smart TVs, heck, even the Mars rover. They're all totally different, right? Different hardware, different operating systems. So how in the world can you build one single app that just works on all of them?
We're going to break down exactly how Java pulled this off. We'll start by looking at what the world was like before Java. Then we'll get into its famous Write Once, Run Anywhere solution, talk about how it helps organize code, see where it's being used today, and then wrap things up.
So first, let's kind of set the stage. We need to go back in time a bit, to a world where every computer basically spoke its own language.
You know, back in the early 90s, things were messy. If you wrote a program, you wrote it for one specific machine. A Windows PC with an Intel chip, a Mac with a PowerPC chip, you name it. If you wanted your app to work on another platform, you had to basically rewrite the whole thing. It was slow, it was expensive, and it was a huge pain.
And then Java shows up with this incredibly bold promise: write once, run anywhere. This wasn't just some catchy slogan. No, this was a total game changer. It was a whole new way of thinking that promised to free developers from being chained to the hardware.
So the big question is, how did they actually do it? I mean, it sounds kind of like magic, right? Well, the secret lies in one of Java's most brilliant inventions, the JVM.
The key to this whole thing is the Java Virtual Machine. And honestly, the best way to think about it is as a universal translator. Your Java app speaks one language, but the computer it's on, whether it's a Mac or a Windows PC or a server, speaks its own native language. The JVM just sits right in the middle and translates between them in real time. It's that simple and that powerful.
So here's how the process actually works. A developer writes their Java code just once, but instead of compiling it for a specific computer, it gets compiled into this intermediate thing called bytecode. Now, this bytecode is universal. You can take that one file, send it to any device that has a JVM installed, and the JVM takes it from there, translating it on the fly so it runs perfectly.
And you can probably guess what this meant for businesses. It was huge. Suddenly, one team of developers could write one piece of code and have it run everywhere. This saved an absolutely massive amount of time, money, and effort. It just completely changed the economics of software development.
Okay, so that's how Java runs everywhere. But that's only half the story. The other big idea is how Java helps developers handle really complex problems. And that all comes down to thinking in objects.
See, Java is built around this concept called Object-Oriented Programming, or OOP. It's really just a way to structure your code that copies how the real world works. You take real-world things, like a customer or a bank account, and you model them in your code as these self-contained objects that have their own data and their own behaviors.
The classic analogy here, and it's a great one, is the blueprint for a car. The class is the blueprint. It defines what a car is. It has wheels, an engine, a color, and it can do things like accelerate and brake. But the blueprint isn't an actual car, right? The object is the real thing you build from that blueprint, that specific red car sitting in your driveway. You can use that one blueprint to create millions of different unique car objects. And why is this so great? Well, for one, your code becomes super reusable. That car blueprint is like a Lego brick you can use over and over again. It also makes huge, complicated programs way easier to manage. It just makes sense because it lets us organize our code in a way that matches how we already think about the world.
Okay, enough with the theory. Let's talk about the real world. Where is Java actually running today? Where is it hiding in plain sight?
And the answer is just about everywhere. But what's really amazing is where it dominates. Almost half of all major enterprise systems, we're talking the stuff that runs banks, airlines, and huge retail companies, that's all Java. It's the engine behind a huge number of Android apps and massive websites. I mean, you have almost certainly used a dozen Java systems today without even realizing it.
And this number just puts it all into perspective. More than 3 billion devices are actively running Java. And we're not just talking computers and phones. We're talking Blu-ray players, car dashboards, medical equipment. Its reach is just staggering. So, after all that, what's the big picture? We've gone over the core ideas that made Java such a powerhouse. Now let's tie it all together and think about what comes next. So, let's just quickly recap the 3 biggest takeaways. First, that revolutionary idea. Write once, run anywhere. Second, the magic behind it all, the JVM, which acts as a universal translator. And third, the smart way it organizes code using blueprints and objects.
So now you get it. You understand the core, fundamental ideas that made Java one of the most important programming languages in history. You get the how and the why. So really, there's only one question left to ask. What problem are you going to solve first?